Okay, we are now on the next problem. Problem number 2. And by the way, there is some kind of brightness here. And the explanation, the same as what I explained to you, why brightness appear here. I hope you just adjust this kind of mode of delivering. If only we are inside the class, face to face, you would not see this one. The brightness here is due to the sensitivity of the cell phone I'm using. I'm using my cell phone. Okay? So here, it's a brightness, it's an open space. Okay. Now, problem number 2 is about a meter stick. So, meter stick, this one, meter stick. Meter stick has a length of, what is the length of this meter stick? What is the length? The length of this meter stick is 1 meter because it is a meter stick. So 1 meter. The length. In terms of centimeters, 100 centimeters. Now in this problem, the person is holding this way. The person is holding this way. That one. Okay. 10 centimeters. 10 centimeters. 10 centimeters. 10 centimeters. 10 centimeters. Okay. So this is 10 centimeters. 10 centimeters. Okay. There is the force exerted by this front. There is a force exerted by the front edge of my hand. My hand. Okay. If you are the one holding the meter stick, your hand. Okay. My hand exerting a force upward. Upward. The force exerted by this hand upward. Okay. Then there is a force exerted by the back portion of my hand, the rear. This one. Downward. Downward. Okay. Upward. Okay. There is the force because if I'm going to release this one, release. I'm going to release the meter stick. Release. What will happen if I'm going to release? I am going to release. Ready, get set, go. It moved down. Why it moved down? Because there is the weight of the meter stick. The weight pulls the meter stick down. And we know in our junior high school physics that the weight is just the pull of gravity. Okay? Every person has a different weight. Okay? Every person. And therefore, every person has a different pull of gravity. Amount, the magnitude. Okay. And your weight, by the way, is computable using universal law of gravitation. Remember the universal law of gravitation in your junior high school physics? That gravitational force is equal to capital letter F equals the universal constant, capital letter G, times M1, M2 divided by the S squared, where the S is the distance of separation between the two masses. Mass is given, distance of separation given, universal constant as a constant value equal to 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. Okay. Now, that's computable. So there is that force. Pull of gravity equals the weight. Distance 50 centimeters because if this meter stick is uniform, meaning to say the width here equals the width here. The thickness here, thickness equals the thickness here. Okay? So uniform. Okay. Dili kay tambok, niwang, nipis, baga. Okay. Now, so uniform. So the weight is considered to be at the center of the body. Center of 1 meter is 0.5 meter or 50 centimeters. So that's why we have this one. Now, A and B, we call that the pivot points. In the next problem, instead of writing A, I write P1, P2, pivot point 1, pivot point 2. But generally, we can also have this one as A and B. A and B. Pivot point 1, pivot point 2. When we say pivot point, it is actually the axis of rotation. Just like your arm. Where is the axis of rotation? Here. Here. Axis of rotation. Axis of rotation. Axis of rotation. This one. Okay. This one. A. Axis of rotation. Here. Axis of rotation. Okay. So, that's why we have that symbol. A. Now here, you are asked, the problem is asking, okay, calculate these forces. No. Okay. Calculate these forces. What are the forces to be calculated? The forces to be calculated will be the force coming from this front, this one, the force, and the force, because the force exerted here is different from the force exerted here. Okay? Different in direction. But because we are in equilibrium, okay, forces or the torques that will be created by the forces equal 0. Okay? The torque that will be created equals 0. Because we are in equilibrium. Okay? Now, after having this, we are going to have a sketch. So this one is the sketch now. Okay. This is the force F going upward. Going upward. This is the force going downward. This one. Downward. So downward. Okay. Back. Okay. And so, we are going to have what we call axis of rotation or the pivot point. Let us consider A as the pivot point or the axis of rotation. So, because there is now rotation, we are going to involve the second condition of equilibrium, that the summation of the torques equals 0. First condition of equilibrium is summation of forces equals 0. Second condition of equilibrium, summation of torques. Torque, symbol of torque. Actually, it's a little similar to letter T, but there is something like that. Okay. That's torque. Okay. It's a Greek letter. Now, equals 0. So what we did here, in problem 1, we do the same. We have for x here, we have summation of x component equals 0, summation of y component equals 0. Here, summation of torque along the x equals 0. Or here, by the way, torque is no longer along the x, along the y. Torque here will be based on rotation, counterclockwise rotation and clockwise rotation. The meter stick counterclockwise, counterclockwise the direction against the direction of a clock, mechanical clock. Counterclockwise, the torque there is positive. Positive. For clockwise, this one, clockwise direction, clockwise rotation, negative torque. Okay. So, you have here counterclockwise torque. Okay. Counterclockwise torque equals 0. Clockwise torque equals 0. Okay. Now, let us, now, in this case here, in this case, for forces, there are no horizontal forces. There are no forces along the X. All forces are vertical forces, vertically upward, vertically downward. There is no force along the positive X, along the negative X. So, we do not mind this one anymore. We will mind this. Okay? Okay, now. So, this one is a force directed toward the negative y-axis. Okay. Drawing naman tayo. Drawing. Positive y, negative y. Positive x, negative x. Force is here for W going down. This W. For this force also going down. This force going down. Back force. For this force going up. F, the front force. So all are vertical forces. Okay. For vertical forces here, for this one, the force is directed toward the negative y-axis. So this is a negative force. So we will consider, let's say, this one is our F1. This one is our F2. This one is our F3. So there are three forces acting. Force due to the weight, force due to the back portion of the hand, force due to the front edge of the hand. Okay, front edge of the hand. The front edge, okay, front edge. Here. I will repeat, I will repeat. Back, the front. Okay, the front. This one, front. Hand. Front edge, back edge. Front edge, back edge. Okay. So the front edge distance from a 10 centimeters. That's the distance. This one, the back, is right at A, the pivot point or the axis of rotation. Okay, now, so for the summation of the y here, we go here. Malibog na mo. This one, there is F, Y, okay, or this is just, we can have this one as the force in general. Okay, anyway, no need to distinguish this one either Y or X because there is only one single, okay, kind of force, vertical force. Of course, the direction is either upward or downward, upward positive, downward negative. Okay. So, our F, therefore, here, summation of F, therefore, is equal to F1 plus F2 plus F3 equals 0. Why 0? Equilibrium. Okay. Why equilibrium? Steady. Do not move up there, do not move down. Steady. So equilibrium. No motion, no motion. Stationary, no motion of the meter stick. Okay. So equilibrium equals 0. Okay. Now, so you have our F1 here. Our F1 is equal to the weight. Okay, F1 is the weight. Okay. Our F2 plus by the way, weight is negative, going down, going to the negative y-axis. Then our F2, this one, also negative, going down, look at the arrow, going down. This is FB, the back portion of the hand. And our F3 is positive, going up, the front, F sub F, equals 0. Okay. Now, there are 3 variables here. 1, 2, 3. 1, 2, 3. 3. Weight is known. FB, unknown. F sub F, unknown. FB, the back portion of the hand. FF, the front edge of the hand. Okay. Unknown. So, what we can do here is, from here, I will transfer here. So, I will have F is equal to, I will transpose is equal to FB, okay, plus W. From here, oh, this one. This becomes positive because I transpose. This one is positive because I transpose. So, from negative FB, positive. From negative W, positive. Okay? What remains this one? This is positive. Okay. We cannot solve for F sub F because this one is unknown. Now we go to the second condition of equilibrium about the torques. Because we cannot solve this one using the first condition. We go to the second condition about the torques. Okay. I'm going to erase this one, ha? Erase. Okay. Now, next condition. Summation of torques. Summation of torques equals 0. Okay. Now, when we say torques, we are referring to that physical quantity that is responsible in the production of rotation either clockwise or counterclockwise. Okay? Clockwise or counterclockwise. So, when there is rotation, okay? When there is rotation, in the case this one, there is this pivot point or axis of rotation. This is now the moment arm or the lever arm. Okay? This is the moment arm. Now, in the case, because there are how many torques acting here? How many torques? By the way, torque. Okay. How many torques? There are how many torques here? How many? I will answer my question. Because there are 3 forces, there are also 3 torques. Clear? Okay. So what are these torques? Okay. This one is torque 1, torque 2, torque 3. Okay, torque 3. So there are 3 torques. So torque 1 plus torque 2 plus torque 3 equals 0. Okay, now we are going to supply what kind of torque? Clockwise or counterclockwise torque? Okay. If this is the axis of rotation, this torque due to the weight will have a clockwise rotation. Okay? This torque will have a counterclockwise rotation. If this is the axis, the pivot point. Okay? So, this is the meter stick. The weight will give a clockwise rotation. When there is rotation, this is a fixed end, this is a free end to move. But this one is fixed because this is the axis. Okay? So the lever arm, the moment arm will be the one to move around this axis. Okay? The weight will cause a clockwise rotation. If it is a clockwise rotation, therefore, this is a negative torque. Clockwise rotation. Negative torque. Okay? This one will give, because it is upward, will give a counterclockwise rotation. So, counterclockwise rotation, this torque is a positive torque. Now, how about this one? This one is right at the axis of rotation. This force, right at the axis of rotation. So therefore, it does not, okay, move away from the axis. It remains there. Okay. Now, in torque, formula of torque is equal to force times the moment arm, r sine theta. Now, our theta here, okay, r sine theta, our theta is 90 degrees. Okay? Our theta is 90 degrees. Okay. In the case of the weight, the angle here is 270 degrees. Now, sine of 270 degrees, you have negative. That's why it is negative. It's negative. That's why it's negative. Because if we use the angle 270 degrees, because this angle is 270 degrees. Remember the negative y-axis, that's 270 degrees. Okay. That's why you have negative here. Or another way of saying that any torque that will give, okay, or any torque that will give a clockwise rotation is a negative torque. Clockwise rotation. So this one, F2, this one is right at the axis. We don't have any problem. What direction? It's at the axis. There is no clockwise, there is no counterclockwise rotation. But this one will be positive. This is positive. Okay, positive. And so, if it is positive, this one is positive. Okay? You will have negative torque 1, negative torque 1. Okay? This one will have no rotation. This plus 0 at the axis. Okay? Then, this one is positive. Plus torque 3. Plus torque 3. Equals 0. And therefore, you have torque 3. Torque 3 equals torque 1. You get that? Torque 3 equals torque 1. 0. Okay. Or if you want to solve this one, okay, it will still result to 0 because our torque here, force, there is a force, FB, R, this is the distance from the axis, the distance of FB is 0, that's why 0, this is sine of theta, but any angle, whatever angle, multiply by 0 is 0, and so that's why you have 0 here. Okay. And so you have that. And therefore, by the formula, torque, sine, this will become R, force times the moment arm, okay? Force times the moment arm, or the moment arms times force, because you can write this one as R sine theta, okay, times F, the same as F times R sine theta. Remember, A times B equals B times A, provided that B is not a vector, A is not a vector, because if it is a vector, then it will be different. Or in numerical values, 2 times 5 equals 5 times 2. So we can interchange that. So you have R3, F3 equals R1, F1. Our R3 is the distance of, remember our F3 here, our F3 has a distance of 10 centimeters. Or 10 centimeters, this is 10 centimeters. 10 centimeters. F3 equals distance 50 centimeters times F1. Okay? And so, our F3, okay, our F3 therefore is equal to 50 cm over 10 cm F1. Then our F1 equals W. You can solve the problem. Just do the proper substitution. Do that step by step. For the next problem, this problem is easier for you to do because this is a continuation of example 1 of chapter 1. You read example 1 of chapter 1, chapter 14. We are on chapter 14. This is example number 1, solved in detail by the book of example 1. And in this problem, number 3, is a continuation of example 1. Okay? So do that. Okay? And by the way, this coming Saturday, we are going to have our video class. Okay? Online class, video discussion. This coming Saturday, May 16. Don't be absent. We will start at 1:30. Okay? So, if you have, what happens if your internet is weak at that time? Or no internet at all, there is a brownout. No problem, it's recorded anyway. But it will be better if you can participate. Okay, it's recorded. Our Sol in Seliman, automatic. The video discussion is recorded. You can just go to Sol and look for the recording of our class, video class, using big blue button this coming Saturday. During our time, and our time is 1:30 to 4 o'clock. Okay? Bye. Huh? If you have some problems, you can email using the Sol also. Okay? For those who have not submitted on time, okay, because there is always a deadline, just continue to submit. Okay? Just continue to submit. But those who will submit that on time will have what we call some kind of higher score. Higher score because they submitted in time. Now, sir, suppose, sir, we would like to submit but our internet speed, sir, very slow, sir. Oh, well, let us try. Let us try. Let us try to just submit that. I'm going to evaluate also the kind of work you perform because you have longer time. Remember, if you submit late, you have longer time to solve it. Solving the same problems as others are solving the same. Okay? Bye.